guys, if you find this video helpful, please like, subscribe and press the bell icon for notifications. So guys, today we will be learning about adjoint of a matrix that is denoted by ADJ, that is adjoint of matrix A or A in bracket. Both are the same thing. So adjoint of A is equal to the transpose of Aij of a square matrix, that is cofactors of Aij. So first we need to find the cofactors of each and every element of the square matrix, and then the transpose of those is the adjoint of a matrix. Now let's take a square matrix A with elements A1, A2, B1, B2 of order 2 by 2 and find out the cofactors of each elements of this matrix. So cofactor of A1 is -1 to the power 1 plus 1, and if we eliminate first row and first column, only B2 is left, so it will give us B2. Now cofactor of A2 is -1 to the power 1 plus 2, and if we eliminate first row and second column, B1 is left, which will give us -B1. Now the cofactor for B1, which is in second row and first column, is -1 to the power 2 plus 1, and if we eliminate second row and first column, A2 is left, which will give us -A2. And the cofactor for B2, which is in second row and second column, is -1 to the power 2 plus 2, and if we eliminate second row and second column, A1 is left, so it will give us A1. So now adjoint A is equals to transpose of cofactors of Aij, and we know the cofactors now, so we can write B2 minus B1 minus A2 A1. Now the transpose of this matrix will be interchanging rows and column. So take first row, that is B2 minus B1, and write it down as first column. So first column will be B2 minus B1, and now take the second row and write it down as the second column as minus A2 A1, and this is the adjoint of A. So as we can see here, adjoint for a 2 by 2 matrix is simply interchanging the elements at A11 and A22 and changing the sign of the elements at A12 and A21. So for a 2 by 2 matrix, we can find out adjoint A without finding the cofactors. But for 3 by 3, we need to find cofactors for each and every element of that matrix. Now let's take an example with matrix A with element 2, -1, 3, 4 and find it adjoint A. So adjoint A can be found out by interchanging 2 and 4. So we can write 4 in place of 2 and 2 in place of 4, and then change the sign for 3 and -1. So -1 will become 1 and 3 will become -3. So this is one way to find the adjoint A without finding the cofactors. Now let's prove this and do it by finding the cofactors. So now cofactor for 2 will be minus 1 to the power 1 plus 1, and if we eliminate first row and first column, 4 is left, so it will give us 4. Now cofactor for minus 1 is minus 1 to the power 1 plus 2. If we eliminate first row and second column, 3 is left, which will give us minus 3. Now the cofactor for 3 is minus 1 to the power 2 plus 1, and if we eliminate second row and first column, 1 is left, so which will give us minus 1 is left, so which will give us 1. Now cofactor for 4 is minus 1 to the power 2 plus 2, and if we eliminate second row and second column, 2 is left, which will give us 2. So adjoint A is the transpose of all these cofactors, that is 4 minus 3, 1 and 2. We can also write it with symbol T and prime, and now the transpose of this matrix can be found out by taking first row and write it down as the first column and the second row as a second column. So 4 minus 3 will become first column and 1 and 2 will become second column. So we can find adjoint of 2 by 2 matrix in both ways. Now let's take an example for 3 by 3 matrix with matrix A with elements 2 0 1 1 1 1 1 2 1. Now let's find out its cofactors. So cofactor for 2 will be minus 1 to the power 1 plus 1, and if we eliminate first row and first column, we will get 1 1 2 1, which will give us 1 minus 2, that is minus 1. Similarly, for the cofactor of 0, it is A12 is equals to minus 1 to the power 1 plus 2, and if first row and second column is eliminated, then the remaining elements are 1 1 1 1, which will give us 0. Now cofactor for 1, that is A13, it will be minus 1 to the power 1 plus 3, and if we eliminate first row and third column, 4 elements, we will get 1 1 1 2, which will give us 2 minus 1, that is 1. Similarly, we can find out the cofactors for elements in second row and third row. So A21 is minus 1 to the power 2 plus 1 and 0 1 2 1, which will give us minus minus 2, that is 2. Now for A22, that is minus 1 2 plus 2 2 1 1 1, and it will give us 1. A23 minus 1 2 plus 3 and 2 0 1 2, and it will be 2 minus 4 minus 0, that is minus 4. A31 minus 1 to the power 3 plus 1 0 1 1 1, that is minus 1. A32 minus 1 to the power 3 plus 2 2 1 1 1, that is minus 1. And A33 is equal minus 1 to the power 3 plus 3 2 0 1 1, which will give us 2. Now write down all these cofactors in matrix form, and we will get minus 1 0 1 2 1 minus 4 minus 1 minus 1 2, and transpose of this matrix will be convert first row in first column, second row in second column, and third row in third column, and we will get minus 1 0 1 as first column, 2, 1, minus 4 as second column, minus 1, minus 1, 2 as third column, and this is the adjoint of A. So this is how we find adjoint for 3 by 3 matrix. Our next topic is inverse of matrix. Thanks for watching.